And then lastly, we come to chemical reactions. So now we understand that when you allow atoms to interact with each other, that creates chemical bonds. Chemical reactions are both the making and the breaking of chemical bonds to create new molecules from original molecules. And so the starting molecules of chemical reaction are called the reactants. And then once the chemical reaction progresses to the end, the final molecules that are created are called the products. Now this is a very simple example of a chemical reaction. We'll spend some more time looking at chemical reactions, particularly in lab. But down in the bottom, we have shown how to write out a chemical reaction. So typically you put the reactants on the left-hand side. So you've got 2 molecules of hydrogen plus 1 molecule of oxygen. And then you draw an arrow to show progress of reaction. So which way is it headed? And then on the right-hand side, you'll draw out the product. So in this case, if you take 2 hydrogen molecules and an oxygen molecule, you can form 2 molecules of water. And in this case, matter was not created. It was not destroyed. All we are doing is we're taking the atoms that we start out with, breaking some of the bonds between them, and rearranging them to form new molecules. You still have 4 hydrogen atoms on the left and 4 hydrogens on the right. 2 oxygen atoms on the left and 2 oxygen atoms on the right. So we didn't lose anything. We didn't create anything de novo. We just rearranged how those atoms are combined together, right? So we broke some bonds and we made some bonds. And again, this is a very simple chemical reaction, but we're going to get a chance to look at some more complex ones. An example of a more complicated series of chemical reactions is the process of photosynthesis. So we're going to spend chapter 10 looking at photosynthesis. And this is a really important chemical reaction that our world depends upon because photosynthetic organisms have the ability to harness sunlight, this energy that comes from the sun, to create organic molecules like glucose, which we then consume as animals, and we get our energy from those glucose molecules. And so on this slide, you see sort of a summarized chemical reaction for this process of photosynthesis. So you take 6 molecules of carbon dioxide, or CO2, plus 6 molecules of water, and with the energy input from the sun, you can create sugar molecules like glucose, which is here shown as C6H12O6, and then also oxygen is released as one of the products of photosynthesis. And so in the picture here, you see a photosynthetic plant underwater going through photosynthesis, and all those bubbles that are attached to the leaves, those are the oxygen molecules that are being created as a result of that process of photosynthesis. And when we look at chemical reactions, all chemical reactions are reversible. Theoretically, it doesn't mean that it's going to happen because maybe it's too high of an energy cost to go in the reverse direction. But theoretically, right, if you take all the atoms on one side and shuffle them around to create new molecules, what's not to say you can't take those molecules and then shuffle the atoms around to recreate the original molecules, right? So the products, when you reverse a reaction, the products of the forward reaction become the reactants of the reverse reaction. And if you, for example, have a chemical reaction that's happening sort of in an enclosed container, nothing goes in, nothing comes out, eventually that chemical reaction will reach what is called chemical equilibrium. This means that the rate of the forward reaction, rate of the forward reaction is going to be the same as the rate of the reverse reaction. This doesn't mean you have equal concentration or amounts of the products and reactants. It just means that you're converting at the same rate. You're going forward and reverse at the same speed.